In this recording, we are going to look at the final topic under the fundamentals of pharmaceutical calculation in Unit 1 for your module. Now, this is called the scientific notation converter that you're looking at on the screen. If you go to Google and type in calculator soup, online calculator, you will see this calculator popping up. Now, it really helped to ease my tension in dealing with exponential notation and scientific notation. Now, numbers can be quite cumbersome to deal with, right? So let's look at this. 360, that's 360. If we want to convert it, calculate to scientific notation, see the conversion, we move the decimal place 1 right there between the 6 and the 0, and 2, which is between the 3 and the 6. So you're moving and creating a decimal 2 places to the left, leaving only 1 number to the left of the decimal. The scientific notation is written as 3.62 for this particular expression. Now, if you should scroll down, the calculator tell you the word form, that this is 360 in the word form. They go as far as telling you that this is the real number, 360. And they tell you that the standard form, which is similar to the exponential notation, is 3.6 times 10 to the 2, not minus 2, to 2, all right, because it's 360. What if we had 0.36 and click the calculator? And let's look at it. Because we are moving the decimal point from in front of the 3 to between the 3 and the 6 to create a whole number, we're moving the decimal 1 place to the right, then that is why we end up having a -1. The negative is telling you that to get the real number, you have to move the decimal to your left. Okay? So 3.6 times 10 to the -1 would have been the scientific notation. If you scroll down to the bottom, it will tell you that this is 3600th, which means 36 divided by 100 in the fraction form of the numerical expression. Now, what I like about this website is that it tells you what you're doing. Let's go. And by the way, I learned the word carrot. The symbol is written, you can type it in ChatGPT or in your calculator, and it means exponential form. The scientific notation, it's a mathematically expressed symbol, the carrot with a C, A-R-A-T. Let's go. Let's look at the rules in this. To convert to scientific notation, the format is A, which is the number, to 1 decimal, times 10 raised to a power, and the power will tell you the movement of the decimal place, right or left. Let's go down here. Move the decimal in your number until there is only 1 non-zero digit. So let's look at the 3. The 0.36 became 3.6. So the 3 is only 1 non-zero digit on your left of the decimal. Then you count how many places you had to move the decimal, and that becomes B. And so because we moved the decimal to the right, it had, so here we go. If you move the decimal to the right, it has a negative number. If you move the decimal to the left, it has a positive number. And this is really it for scientific notation. Write your scientific notation as 1 digit times 10 with the caret, that symbol, raised to the power B, which tells you how much time you're moving your decimal. And that is really it for scientific notation. But is that it for PharmCal? No. You will have to use this now in calculations. So let's move over to the lecture notes where we show you some rules when you're doing your calculations. Let's do the last topic for this unit 1. Many physical and chemical measurements deal with very large or very small numbers. Because it is difficult, I'm right here, to handle such numbers, the magnitude of these numbers and zeros and decimal, we often express them as exponential notation in powers of 10. And that's really to make the number more manageable, right? In the metric system, when we move on to units of measurement, which is under unit 2, we now use the units of measurement, milligram, kilogram, microgram, to eliminate zeros and decimal, okay? How to convert? I just explained this part to you. It was taken from the website. And for those, it's here in the footnote of the lecture notes, right down there where the calculator is that was used to design this lecture notes. So these are real examples taken from the website I just showed you previously, where 121 is a real number. In the scientific notation form or standard form, it's 1. We'd move the, let me see if I can get the pen. All right, so let's look at the rules for using exponents to make your life easier. Students, if you don't remember the rules, all you have to do is convert them into the decimal or the whole number, carry out the math using a calculator, and then convert it back. That's if you don't remember what to do. So what is rule number 1? When multiplying exponential, you add the exponents. Exponents is what 10 is raised to. So in this one, the exponents would be 2 and 4. So 2 plus 4 equals 6. That's what we have down here, right? Let me bold it and I'm going to put it in green. But then now the coefficients, which is the main numbers that you're going to have, your main number. So in this one, the coefficient is 2.5 and 2.5. You multiply those because it's a multiplication. So 2.5 times 2.5 gives you 6.25. And because you add the exponents, then you get 6. So it's 6.25 raised to 10 to the 6. And I'm going to copy this and take you over to the calculator and show you what the real number is. Once it is 10 to the 6, it means that the number is not a decimal. It's a big number that you're dealing with. Let's see what the calculator gives us. We are now over at the calculator. I'm going to plug it in. Remember, it tells you to use the caret, which is the arrow sign up. If I can only find it. Let me see. Right, so I'm copying it again. I, for some reason, not seeing the caret on the keyboard, but we can copy it from the website. Here, we're going to copy it, put it right there. There it is. So 6.25 raised to the power of 6. We're going to click calculate. There we go. And so it's telling us that the real number, see it here? We're going to copy it over, is 6,250,000. So you see the standard notation. Let's move over to the lecture notes. Let's move over. So we're going to write the words. There we go. So it's 6,250,000, and you get the idea. Let's look at this one. For this one, this is a -4. For this one over here, you have a +2 and a -4 for the exponent. So when you have a +2 plus a -4, you have a -2. And so it simply means, as my little arrow here showed, I started working on it before the recording resumed. It means that you're moving the decimal by jumping here 1, 2. And so I think the real number is 0.0625. We are going to copy this and go over to the calculator and see what the real number is. All right, so I have put 6.25 times 10 to the -2. I copied the symbol from over here. We're going to scroll down, and the page is telling us that is 0.0625. Okay, so it's 600 and 25 thousandth. So remember now that this would be in a decimal form. Okay? Don't be confused. So the negative is telling us it's a decimal number. Positive is telling us that it's a really big number, probably in the millions. Okay? So don't be frightened by exponentials. It's not that difficult. Just remember the rules. We learn about the multiplication. What about if you're dividing? You subtract the exponents from each other. So in this one, the exponent is 5. This one is 3. So 5 minus 3 would give you 2. And then the coefficients you would divide as you would a usual number. So 7.5 divided by 2.5 right here gives you 3. So the answer would be 3 times 10 to the 2. So that means that this number is what? Go and check it out, or it simply means that you're moving your decimal by 1, 2. This is 300. 10 to the 2 is 300. That's the real number that you're dealing with, okay? Now, for this one, the principles still apply. You subtract, it's a negative 4 and a positive 6. So a negative 4 minus 6 give you a negative 10. So this is where it gets really, students, if you don't remember how negative and negative subtract and whatever it is, all I do to make my life easier, I convert this, something like this, I convert to the natural form, work it out as best as I can, and then I convert it back into an exponential. So what is, let me show you. So 2.5 to the 6 means you're moving it 1, 2, 3, 4, 5, 6. That means you have how much zeros? 1, 2, 3, 4, 5 zeros. Okay? So that would be, mean that 2.5 times 10 to the 6 times 10, the recording button is in the way. That's why the pause, times 10 to the 6. I want to put it in the, there we go. Oh, this needs to be not in the exponential form. There we go. The recording icon is right above. Okay, this would mean that we're moving our decimal. Let's see. We're going to move 1, so we're adding 5 zeros. So it's 2, 5 with 5 zeros, 1, 2, 3, 4, 5. Okay, you can plug it in the calculator and check it yourself. Now it simply means this number is a decimal number because you're moving the decimal over by 4. That's what you're doing with this one. 1, 2, 3, 4. So you're adding 3 zeros. So really what this is asking you to do is 0.123 zeros 75 divided. That's what this is. You're dividing it. So it's a real big negative number, you know, by 25 with 5 zeros. 1, 2, 3, 4, 5. Can you see how impossible this number is? Hello? Very impossible. How can you have negative 0.0000 divided by such a big number? And that is why you have exponents, because can you imagine writing 3 to the negative 10? You know what zeros and zeros and zeros that is? And so exponential notation, students, helps you to get rid of zeros. Now the last one is addition and subtraction of exponential, right? And it says the expression must be changed into forms of a common power. A common power, okay, must be there. So if this is 10 to the 4 and this is 10 to the 3, change everything to read 10 to the 4 and 10 to the 4. So you convert everything to 10 to the 4, 10 to the 4, and you then simply add the numbers. And that brings us to the end. Whenever you're adding and subtracting, it must be in a common form. So change 10 to the 3 into 10 to the 4, you simply, right, change the form of the notation. So you have the same form and you can add, right, without much stress. Not much stress. Okay? So go through this for me, please. And so you can have an appreciation. So for this one, 10 to the 3, 10 to the 1, 10 to the 3, it means that you need to convert this one into 10 to the 3 as well, so everything can be easily added. And so your answer would be whatever the addition is, and your answer would obviously be 10 to the 3. Okay? Subtraction, you do the same thing, and so you can subtract. So that brings us to a close for standard form and notation. And as I've introduced you to the calculator, go and have fun on the website. Make the numbers relatable to you. The hardest one, I think, for standard notation is the addition and subtraction. Let me go down. Where the rule tell you convert everything. So this is 10 to the 3, 10 to the 3, and this is 10 to the 1. You have to convert this to 10 to the 3. Everything has to be in the same power, right, for you to do your addition and subtraction. That's really it. That is really it, right? And so here in this example, this is 10 to the 4, this is 10 to the 3. You have to convert them into similar things, right? So 1.4 times 10 to the 4 is really 14.0 times 10 to the 3. And so when you have done that, you can now subtract 14 minus 5 to give you 8.9, and then your base form is 10 to the 3, which is consistent, and that's your answer. Now that brings us to a close to all the subtopics that can possibly come on your screening assessment. If there's any topic which is unrelatable to you, decimals, fractions, and remember fractions have many different forms, percentages, all of these are foundation that will come out. If it doesn't come out in this module, when you reach pharmacokinetics in year 3, when you reach to us in pharmaceutics and then dispensing, every module, whether you're a BSc in pharmaceutical technology student or a pharmacy student, every subject have some form of calculation. So if you didn't get the concept for this module now, so for example, we may not give you a lot of exponential notation now, but you may face it again when you do another module, because these are all foundation math that you should get for a good pharmacy foundation. Whether in the pharmaceutical sciences or the clinical pharmacy, these are foundation concepts you should spend some time on to appreciate. With that said, we are now officially finished with all the recordings to complement Unit 1. And remember that we did fractions and is decimals and fractions in our interaction in the lecture session. Thank you so much for watching this video.